Let's solve problem 5.18 for Microelectronic Circuits 8th edition by Sedra and Smith. So a particular N-channel MOSFET is measured to have a drain current of 360 microamps and VGS equals VDS equals 1 volt, and of 160 microamps and VGS equals 0.8 volts. And we want to figure out the values of Kn and Vt for this device. So we have drain currents. I think an important question to ask is, are we in the saturation region or in the triode region? Saturation would mean that VDS is greater than or equal to my overdrive voltage. And the overdrive voltage can be calculated as VGS minus VT. Well, if VDS is equal to VGS, then that means even if VT equals 0, which is not possible, but even if it was, VDS would still be greater than or equal to V overdrive. So we're definitely in saturation, which means our current equation is 1/2 Kn times V overdrive squared, or VGS minus VT squared. Okay, so we're going to make a system of equations with two variables, Kn and Vt, and then we're going to solve for them. So equation 1 will be our drain current of 360 microamps equal to 1/2 Kn times VGS of 1 volt minus Vt squared. Equation 2 will be 160 microamps equal to 1/2 Kn times 0.8 volts minus Vt squared. So now I just need to solve for the system of equation. I'm going to divide equation 1 by equation 2. So we'll get 360 divided by 160 on the left side. So we get 2.25. This 1/2 Kn is just going to divide by 1/2 Kn, so that'll cancel. So we're left with 1 minus Vt squared divided by 0.8 minus Vt squared. So I'm going to take the square root of both sides. So the square root of 2.25 is 1.5. That's equal to 1 minus Vt divided by 0.8 minus Vt. So now we just need to solve for Vt. So I'm going to multiply both sides by the denominator. So we get 1.5 times 0.8 minus Vt is equal to 1 minus Vt. We can distribute that 1.5. 1.5 times 0.8 is 1.2 minus 1.5 Vt is equal to 1 minus Vt. Now we just need to isolate Vt, so I'm going to add 1.5 Vt to the right side and subtract 1 to the left side. So we get 0.2 is equal to 0.5 Vt, which means Vt is equal to 0.2 divided by 0.5, which is equal to 0.4 volts. Perfect. Now we can solve for Kn. So if I take equation 1, so I'll do equation 2, I think that'd be easier. So equation 2, we can isolate for Kn. So Kn is equal to 2 times the drain current divided by VGS minus Vt squared. So that's 2 times 160. I'm going to convert this to amps, 10 to the negative 6 amps, divided by VGS for case 2 is 0.8 volts. Our threshold we calculated to be 0.4 volts squared. That gets us 2 milliamps per volt squared. And that solves the problem. Thank you for watching my video. For any questions or video suggestions, feel free to contact me in the comments or by my email. And I hope you have a great day.